Hello and welcome everyone. We are mechanical engineering students from the University of Malaya, and this is our video assignment for the subject KIG1004 Basic Materials for Mechanical Engineering. In this video, we are going to describe the material used in making a bicycle frame. We are gonna go through the schematic diagram of a bicycle's cross-section, describe the material and its microstructure, and finally relate the microstructure to the mechanical properties of the material. This is the schematic diagram of the cross-section of the bike frame, both vertical and horizontal cut of the body, which we have drawn manually. So, what is the material of bicycle frame? There are many types of bicycle frame materials such as steel, aluminium, and titanium. For this assignment, we have chosen carbon fiber as the material of the frame. Before getting in depth about how a frame comes to be, we should start with an explanation of the raw material. The origin of the carbon fiber is a polymer which is processed through various heating steps into long strings of carbon atoms. The description of these long strings of filaments is about 5 to 10 microns in diameter each, which is 10 to 20 times smaller than the average human hair. All these individual filaments are then bound together to form a thin ribbon or tow. Then, the same things also happen on how a thread becomes a string, which then becomes a rope. Carbon filaments work together to form something considerably strong and lightweight. Then, what is the microstructure of bike frame? Microstructure of carbon fibers represent a bunch of the monofibers whose quantity depends on the carbon fiber's brand, which can change in very wide limits from several thousand to 10,000 of pieces. Each monothread represents nanoporous strong substance which possesses unique electrophysical properties that opens new areas of their application. The model of structure of carbon fiber can be presented in the form of consistently alternating blocks of crystallites, which are connected among themselves by amorphous sites. The structure of graphitized carbon fiber is anisotropic and represents the crystallites condensed among them and the amorphous sites consisting of atoms of carbon. At the edges of fiber, there are areas with radial orientation. Heat-resistant inclusions significantly differ from the main structure of fiber. Moving on to the development of the microstructure. Carbon fiber consists of hexagonal graphene layer network, but the interaction between the layers is so weak that disorder frequently takes place, resulting in the formation of two-dimensional ordering referred to as turbostatic structures. These structures are present with some defects compared to that of graphitic fibers, where interaction is too high to make it three-dimensional ordering. This turbostatic structure is considered to be basic structural unit of carbon fiber. To form various types of microdomain within carbon fiber, this structural unit can join, fold, twist, and split with each other. The internal structure of carbon fiber is not purely homogeneous, but it consists of various chaotic microdomains formed by the structural units. Briefly, carbon fiber is a blend of amorphous and graphitic carbon. In carbon fiber, each crystalline plane consists of aromatic rings where carbon atoms are positioned on hexagonal lattice. All carbon fiber synthesized from different precursors have an organized crystalline structure. This imperfectness in crystalline structure can be defined as stacking disorder in between neighboring graphite layers or defects in single layer or stacked layers. Now, we will relate the microstructure of carbon fiber materials to its mechanical properties. The carbon atoms are bonded together in microscopic crystals that are aligned parallel to the long axis of the fiber. The crystal alignment makes the fiber incredibly strong for its size. Several thousand carbon fibers are twisted together to form a yarn, which may be used by itself or woven into a fabric. The yarn or fabric is combined with epoxy and wound or melded into shape to form various composite materials. Eventually, this type of microstructure makes the carbon fibers stronger, lighter, and stiffer. We have come to the end of our video. Thanks for watching, and if you find this video is beneficial, please like and share this video and do comment below. Till next time.